Welcome to our comprehensive guide on compiling a Linux kernel, an essential skill for advanced Linux professionals. Customizing your kernel allows for optimized performance and enhanced security. Today we'll navigate through the steps of configuring, compiling, and installing a Linux kernel, ensuring you're equipped with the knowledge to tailor your system's core. /usr/src/linux/ is the traditional directory containing the Linux kernel source code. Accessing and understanding this directory is crucial for anyone looking to customize their kernel. It's the starting point for configuring and building your own kernel version. Kernel makefiles are the backbone of the compilation process, dictating how the kernel is built and installed. They provide a set of directives and targets for Make, a tool that automates the kernel compilation. Understanding makefiles is key to effectively customizing and compiling your kernel. Across different kernel versions such as 2.6, X3, X and 4, X, there are specific make targets to be aware of. These targets like make menuconfig and make bzimage are essential for configuring and compiling your kernel. Each version may introduce new targets or deprecate old ones, adapting to the evolving Linux ecosystem. Output. Customizing your kernel starts with make menuconfig, a graphical tool that allows for intuitive configuration. Whether optimizing for performance or enabling specific hardware support, this step is where you tailor the kernel to meet your system's needs, showcasing the flexibility of Linux. After configuring, the next steps are to build your new kernel and the appropriate modules using make and make modules_install. This process transforms your configuration choices into a running kernel, optimized for your environment. Once the kernel is installed, it's vital to ensure your boot manager, like grub, is updated to locate the new kernel and associated files. This step is crucial for a smooth transition and to avoid boot issues with the newly compiled kernel. Module configuration files play a significant role in managing kernel modules, dictating how modules are loaded and interact with the kernel. Understanding these files allows for sophisticated control over your system's hardware and software interface. Dynamic Kernel Module Support, or DKMS, is a framework that simplifies the process of compiling and installing kernel modules across different kernel versions. It ensures that modules are automatically rebuilt when updates occur, offering a seamless and maintainable system setup. A Dracut is an advanced tool for generating the initramps, a temporary root file system used during the boot process. It's especially relevant when working with custom kernels, as it can dynamically adjust to include the necessary drivers and modules for successful booting. Output.